Hi, in this problem, we're going to be implementing Argmax, a function that takes in a list and returns the index of the largest element in list. If there are two or more elements that are the largest element, return the index of the one that appears first in list. You can assume all elements of list are non-negative integers, and that list has at least one element and no nested lists. Okay, so we're given the skeleton code for this question. And so we're implementing the function called Argmax, but actually inside of the body of this function, we are also given a helper function called maxHelper. And helper functions are helpful in that they allow us to track variables across recursive calls. So for example, Argmax is trying to find the index of the largest element in list. And so what we want to do is we want to use recursive calls to go down the rest of list using coulter list. And based on whether or not we find an element that's greater than a max that we've found so far, we update the values accordingly. So that's what makes our helper function maxHelper so useful, because we can keep track of the max so far, we can keep track of the index of the max element so far, as well as our current index. Okay, so in our helper function, we have a cond statement, but actually it might be easier for us to make our call to maxHelper before we even define maxHelper. So we can see that maxHelper is actually called down here inside of Argmax. And what we want to do is we basically want to initialize all of our values to maxHelper. What do we want to start everything out at when we're just starting with the entire list without going down the rest of the list yet? So if we think about what we're starting off at, max so far, because we can assume that all the elements of list are non-negative, we can assume that max so far is actually going to be 0 when we're just starting out. So we'll start max so far off at 0. And then we need to figure out what our max index is going to be if we're just starting out. That is also going to be 0. Oh wait, sorry, we forgot to pass in list. So we have to pass in list. Max so far is 0. And then max index will also be 0. Because the instructions also say that list has at least one element. So if we think about it, if we called maxHelper on a list containing one element, because the indices of the list are 0 indexed, we are actually just going to return 0 if it contains one element, which is correct. And then finally, current index would also make sense to start off at 0. So that is our recursive call to our helper. I mean, not our recursive call, just our call to our helper function, maxHelper. Okay, so now that we've called maxHelper, we need to think about how we're going to define maxHelper. We're given multiple lines to check certain conditions and make certain calls and return certain things based on these conditions. And because we are working with a scheme list, which is similar to a linked list in Python, we can figure out that we are going to be using recursion to go down the rest of list. So basically, a lot of our scheme list problems make recursive calls on coulter of list. So it goes down the rest of list until list is null. So that's a familiar pattern. So then we can figure out that one of our conditions is definitely going to be checking if list is null. So that means if we have no more elements left in list. If we have no more elements left in list, our max the index of our largest element so far is actually just going to be max so far, and that's what we want to return. So we're going to return max so far if there are no more elements left in list, or if list is null. Okay, and now what is another condition that we're going to have to check? So this is our first condition, and then our second one is actually going to be both of these lines here, because you can see that there's no parentheses. So our code, oh my gosh, I can't spell. No parentheses, or no parenthesis. There's no closing parenthesis there. So that means that these two lines are actually going to be part of the same condition. It's just something to note, since in Scheme, the indentation and the new lines don't matter. This is just because we've run out of space, and this call is probably going to be pretty long. So what is our second condition? Because we're trying to find the max so far, what happens if the first element of list is bigger than our max so far? So this is where we're going to check for that. So how do we do that? If the first element of our list, so we can use car of list, is bigger than our max so far. If that's the case, what should we do? Okay, so this is our condition here. If that's the case, we need to update all of our values to reflect this. So now our new max so far is going to be the first element of list. So we can make our recursive call to max helper. List, okay, let me just erase this. List is now going to be cutter of list, because we want to now check the rest of list. Max so far, because car of list is greater than max so far, we're going to update max so far to be car of list. So remember that this next line is part of this recursive call here. We're just starting on a new line because we've run out of space. Okay, so now that we've handled, now that we've updated list to be cutter of list, we've updated max so far to be car of list, now we need to set the max index. So max index is going to be cur index, because our current element, or car of list, is now our new max so far, so we need to update our max index to be our cur index. So this is why we're keeping track of cur index. And then now we need to update cur index to be cur index plus 1. Because now we are calling max helper on the rest of cutter of list, and we are now going down one element. So our current index is now going to be current index plus 1. So this is our recursive call to max helper if we found an element that is greater than our max so far. Okay, so now what is our third condition that we're going to check, our third and final condition? We've handled if list is null, we've handled if the first element is greater than max so far. And now there's only two other possibilities. The other possibilities are if car of list is equal to max so far, but if we look at the spec or the instructions, it says return the index of the element of the one that appears first in list. And so the reason why we are only doing greater than and not greater than or equal to is because we just want to set max so far to be the first max element that we find. If we find one that's equal to it, we don't want to update cur index. We don't want to update max index, because we want the max index to be the first occurrence of that element. Okay, so the very final case would be if car of list is less than max so far. In this case, all we want to do is we still want to call max helper, because we want to check the rest of our list to see if we can find any elements that are greater than max so far. So we're calling max helper on cutter of list. Max so far is still going to be max so far because we haven't found anything that is greater than max so far, so that doesn't change. Max index also doesn't change for the same reason. And finally, we have to update cur index to be cur index +1 because we are moving down the list. And that is everything.